Okay, so this is part 3 of chapter 3, sensory and perceptual development. We will look at the following topics: what are sensation and perception, the ecological view, visual perception, and a brief look at other senses. Those last 3 topics you should be reading on your own. I'm not covering them, which is why I've crossed them out, but you are still responsible for them. So let's begin with what sensation and perception refers to. Sensation is when it occurs when information interacts with your sensory receptors. So information meaning, environmental stimuli. And our sensory receptors are our eyes, ears, tongue, nostrils, and skin. We use all of these to sense the world around us. And so sensation for sight is when light waves, reach my eyes. And the eyes then convert the light waves into neural impulses. When sound waves hit my ear, the ear converts the sound waves into neural impulses. When taste molecules hit, the sensory receptors in my tongue, it converts it into, you guessed it, neural impulses. And the same with the other two. There are odorant molecules that get converted into neural impulses, and your skin has different types of sensory receptors to detect touch and pressure and heat and cold, and they all get converted into neural impulses. So that's the job of sensation, is to transmit all these different stimuli from the world, smells and sights and sounds and touch, and into neural activity or neural impulses, so that our brain can then interpret them. That's where perception comes in. So these neural impulses that the sensory receptors have all produced, get analyzed in our various sensory cortices, like your visual cortex and your auditory cortex, and when they're analyzed, that perception occurs, and you interpret what you have sensed, what that raw data is. So I look at a table, and light rays bounce off of it. They go into my brain. My eyes convert the light rays into neural impulses. They travel back to my visual cortex and at the very back of my brain in the occipital lobe, and then I know I'm seeing a table. Okay, let's go on. The ecological view. Ecological theory, if I don't know if you remember from chapter 1, but it's kind of it's based on evolutionary ideas, and things develop for a reason, so that we can adapt to our environment. And so they say that the ecological view says that perception has developed to bring us into contact with the environment, so we can interact with it and adapt to it. It's designed for action, so it gives you information to act on. So if a ball is coming towards you, you act on it by putting your hands up and catching it. Or if you see the car in front of you braking, you act on it and you brake, so you brake behind them so you don't crash into them. Anyways, so the ecological view just says that this is adaptive, and so through evolution, our perceptual abilities increased, and because those that had better perception and sensation and perception would survive longer. And that's about all that says. Okay, how do we study infant perception? A couple methods we'll talk about here. The first one is the visual preference method. This method determines whether infants can distinguish one stimulus from another by measuring the length of time they attend to to different stimuli. So this has been around for a while, this method. I'm going to go ahead to the next slide. And so I threw this picture in, and this is an it was a very important early study by Fantz in 1961. And he made this device where he studies what infants prefer to look at. And so he would give them choices, and you can see the stimuli that he initially used over on the right side. They would get choices between pairs of stimuli. So on one trial, they might have the face and the yellow egg and the yellow oval. It's not really an egg, but other times they would get that bullseye looking thing versus a red oval, let's say. Anyways, and so he would look down. He was like observing them through this machine to see which stimuli they were moving their eyes towards. So they would always have a choice between two, and he would look, are they moving their eyes left or right? You can see the baby laying underneath the machine. So this was a old-fashioned kind of research device to look at infants' preferences. And just to go over his findings a little bit there, I mean, this was one of the first times that we discovered that infants really prefer looking at faces. And you can see that the percent of time they spent looking at the face is much greater than any of the other stimuli. And he also discovered that they like more complex stimuli. So that oval with the words on it and the one with the bullseye, I mean, they're more complex than just the colored ovals or the white oval, and they spent more time looking at those. Infants like dark versus light patterns, like black and white patterns. And some say that this is one of the reasons that they will look into adults' eyes, their caretaker's eyes, is because of the black versus the white in your eye. Okay, I'm gonna backtrack here. So that's one method, visual preference method. They also use habituation and dishabituation to study perception. And habituation is when an infant decreases their response to a stimuli after it's been repeated often. And so habituation just means they lose interest in the stimuli. So, let's say maybe I'm testing sound and I play a little short tune, and what we would see if it's the first time the infant hears it, they would orient towards it. I mean, they would make a response to show that they're listening to it. And if I keep playing the tune over, I mean, for a while they'll show that response, but at some point they'll stop responding to it. Or if I'm showing them something visually, at some point they just won't look at it anymore. They won't. It'll be like, I've seen that. I don't really need to see it again. And that's habituation when they stop responding to it. Dishabituation is when they show a recovery of that orienting response. So what you can do is you can present one stimuli until they habituate to it. So they once again they get to a point where I'm bored of this. I don't want to look at it or listen to it anymore. And then you could change it slightly. And if they can detect the difference, they will show dishabituation. All of a sudden, like, wow, that's new. But let's say it's the change is too slight and their visual perception abilities can't notice the difference, or they can't, their auditory perception can't notice the difference in the sounds. They'll continue to show the bored response, the habituation response. So they use this to see if they can discriminate between different stimuli. So you play one musical note, then you play a slightly different musical note, like after they've habituated to the first one. And if they can tell the difference, you know that they have that ability, that perceptual ability. They can tell the difference between these two sounds that are very similar. So you can test, and you can do that. You can test, different senses using this method, habituation dishabituation method. Okay, another way more modern way we've been studying infants is we look at orienting responses. I just mentioned that term. That's when they turn towards a sight or a sound. They orient towards it, and we study this using now, instead of just looking at, hey, what are they looking at? Like Fantz did here. He has to kind of figure out what exactly the baby's looking at. Now we use very sophisticated eye tracking headgear, um, which tells us exactly what the infant's looking at. It's amazing equipment. I mean, it pinpoints like precisely where the infant's focusing its vision. Some say that this is the most important recent advance in measuring infant perception, the development of this sophisticated eye tracking equipment. Um, okay, so it measures eye movements. Um, as an example, they can measure eye movements of the infant as it's looking at a moving object, for instance. And so you could see, can they track that object that's moving, um, or are they just kind of looking close to it? I mean, like, can they actually keep their vision right on the object? I mean, you can't tell that by looking at the infant, and you can kind of see if they're looking towards an object that's moving, but this will precisely tell you, like, are they focused right on it? Um, it also tells us things like they've done studies of what infants look at in a human face, and they've drawn little maps of like where the gaze went. It went, first of all, they looked at the mouth, then it moved up to the left eye, and then it moved over to the right eye, and anyways, and because it's that precise, you can see exactly where they're focused, and this is where they found out that they really like to look at eyes, because of the whole face. They spent a lot of time looking at the eyes. They also looked at the mouth a lot. And so this equipment told us exactly what they were looking at. And so it's pretty amazing that you get a sense of, of, you can see exactly where this baby's looking, because it uses this, you know, um, some kind of like laser, like infrared laser technology to bounce the light off of their eyeball or something like that. It's and it sort of pinpoints what they're looking at. It's pretty cool. Okay. Anyways, um, so using this equipment, they can study all these different things. They look at it assesses aspects of infant looking. Okay, you can see where they look, their gaze, their attention. Um, are they holding their attention on something, or is their gaze wandering? You can actually study memory with this. I'm not going to get into it. Face processing, I already kind of talked about that. What they look at in a face, and so it's really advanced our understanding of the visual system perception of infants, and we can tell between, for instance, a normally developing child and an autistic child. They have different gaze patterns. Okay, let's look at the senses fairly briefly. I mean, start at visual acuity. Um, um, it's estimated that a newborn has 2,600 vision. So remember, like 2020 is like normal vision. So they were at 2,600. Uh, that means that, like, if you were looking at something 600 feet away, which is a good distance, and like it would probably whatever you're looking at would look kind of fuzzy, and it would be hard to see the details. I mean, that would be like what they're looking at 20 feet away. So it's the same lack of clarity. I mean, anyways, this is 2,600. Just to put it in perspective of how bad this initial vision is, we consider 2,200 as being legally blind. So this baby is basically legally blind at birth, even though they are seeing very fuzzy, distorted images. Um, but it develops rapidly, as this next point makes. I mean, it improves from fuzzy at 1 month to clear at 1 year. So, within the first year, their vision develops rapidly. We'll see an example on the next slide coming up. Within hours of birth, newborns prefer looking at faces over other objects. Remember, Fance was the first one to show that. They've shown it in other studies now, like using real human faces. With the eye tracking equipment, we can see exactly what they like to look at. The color vision, by 4 to 8 weeks, color vision develops, and then by 4 months, babies prefer saturated colors. So at 4 months, they like things that they like. Saturated colors means they like things that are full of color. Okay. This is what I'm talking about. So this is an estimate. We can't tell for sure, but what what a baby's perception is like at different times. That first picture is from 1 month of age, and so at the newborn stage it would be even fuzzier. But so at 1 month they're getting kind of a fuzzy picture of their looking at their mother's face. I mean, the next one is 2 months, so you can see it's already improved. The next one's 3 months, so it improves rapidly. And then that last one is 1 year, and that's basically looks to me like what I would see. So I mean, they have good vision by the end of the first year. This is I want to show you. This is how they study depth perception. They use what's called the visual cliff, and you can see they have a setup here where they have this this plexiglass covering, and on one half of this, I mean, it just looks like the baby just looks like they're on the ground normally on the far side, but then on this closer side, I mean, it looks like a huge drop off. Even though there is glass, I mean that baby can't fall, but it looks like a drop off, right? So if the baby can recognize that drop off, it will stop, like right where this baby is right now. He's got one hand over, but but even though somebody's calling to him and showing a toy to the baby, if they can see depth, they won't come any further. If they don't see depth, they'll just crawl right over it. So you can test to see if they have depth perception yet. So it's an interesting little experimental setup to test that. When they study 6 to 12-month-olds, most don't crawl over. So in the second half of the first year, most a typical infant will have depth perception. Crawling experience helps. They found that babies that crawl versus those that don't, develop depth perception quicker, because they're getting experience in the world. Like when they crawl about, they're learning about depth. I mean, they'll see something that's a little distance away, and they'll crawl to it. And so this gives their brain information about, that's how far away that was. Because now they crawled right to it. And so, anyways, what else I want to say here? Most infants develop the ability to use binocular cues to depth by about 3 to 4 months of age. Binocular cues means cues that depend on both eyes. Okay, so typically they're starting to develop depth perception at 3 to 4 months of age. Let's go on here. Other senses. This will be the last slide for the section that I cover. And actually, I'm actually going to skip the hearing. I don't have anything to add to it. I mean, you can read about this easily enough in the book. You can see how their hearing changes during the first year. I'll cover the bottom part. Newborns are sensitive to touch and pain. Recent research has indicated that infants can feel pain. And you may say, well, why would we ever doubt that? But it was, it was disputed in the past, and we weren't sure, because not all of the perceptual abilities are well developed at birth, and so it was possible that your pain receptors weren't really working, and some people assume that babies didn't really feel pain, but with newer research methods, we've established that they definitely can feel pain, and so this is because of this finding. This has now led to anesthesia being used more in circumcisions, because it was never used in the past. But now that we know that it really does hurt the baby, more and more people are using some form of anesthesia in that case. I smell. Um, I guess I'll just say it is established at birth. Their smell system is working. Their smell system. They can differentiate between different odors. They've shown in experiments. Um, some of them have preferences right after birth. Uh, Typically, newborns like the smell of vanilla and strawberries, for instance. They dislike the smell of rotten eggs or fish. So they already have preferences. I mean, built-in preferences. Um, some preferences take experience to develop. They're not born with them. So those ones are ones that we figure they're born with, liking vanilla and strawberries versus rotten eggs and fish. But they did a study showing that um, 6-day-old infants prefer their mother's breast pad versus a clean breast pad. So if a mother's been wearing a breast pad around, it's gotten the mother's smell on it, and the 6-day-old infant can tell and likes that one better than a clean one. But this does not show up at 2 days. So when they tested 2-day-olds, they didn't have a preference. So this shows us that somewhere between 2 and 6 days, they learn to prefer the smell of their mother, versus a clean pad. So that was kind of a cool little study showing that they were quickly developing smell preferences. I'm not going to get into taste, but some of these results are similar. That they do have some preferential tastes when they're born. I guess I'll talk about a little bit. Often their preferential tastes will depend on what the mother's been eating, particularly in the last months of pregnancy, because the fetus experiences the taste that the mother eats as they get nutrients from the mother's system. So they've shown experiments that they'll have the experimental group eat certain things over and over during the last months, and they'll have the control group just eat a regular diet. And so let's say all of a sudden the mother eats broccoli like every day for the last month or something, and I mean the baby's going to be born liking the taste of broccoli. This also, by the way, happens during breastfeeding as well. Taste preferences can be passed to the baby from the mother's system through her milk. Her milk gets flavored with what she's been eating, in a sense. A little bit flavored. I mean, it's not. You know, you would. I mean, it's a touch of flavor. Okay, it's not like all of a sudden, wow, this milk tastes exactly like broccoli. No. Okay. But anyways, so you can read more about that in the book. And this concludes video 3.